Greetings, chemists. This video will be our first video on matter. And so we're going to talk about classification of matter. So let's go ahead and dive right in here. We're going to talk first about what is matter. And if you look here, just down here below, it says right here, matter is anything that takes up space and has mass. And then the next question is, what are the four states of matter? And they are solid, liquid, gas, and then the fourth one is the one we're not as familiar with, and that is a plasma. Okay? So everything in our universe is made up of matter. We break down it into various organizational categories. So a pure substance is matter as everything has exactly the same uniform composition. It can't be broken down into anything, into simpler substances by any normal physical and chemical means. Yes, when we talk about the atom is the simplest thing that we can go down to. Yes, now that we know we can do atom smashers and break the atom apart into quarks and leptons and Messiers and fermions and all sorts of things, but that's not by a normal physical or chemical mean, okay? So something normal, okay? So element, okay, cannot be broken down into any similar substance. And again, I mean by a normal physical or chemical mean, okay? So copper wire, aluminum foil, that's as far as we can go with it, okay? The simplest unit of an element that keeps the chemical properties of the element. Each element is made of only one kind of atom. So again, copper wire is only copper atoms. Aluminum foil is only aluminum atoms, okay? One pet peeve of mine is when people call aluminum foil tin foil. Tin foil is made out of tin atoms. Aluminum foil is made out of aluminum atoms. When you are cooking, you are using aluminum foil made out of aluminum atoms, not tin foil. Little pet peeve of mine, okay? Molecules made up of two or more different atoms, and they can be the same type of atoms or they can be different atoms, but they are in a fixed ratio. Properties have the same from those of their individual elements, and chemical bonds hold them together. So oxygen, O2, it's a fixed ratio. Two oxygen atoms are held together, and it retains the properties of those atoms. It retains the properties of those oxygen atoms that are held together. Compound. Two or more simpler substances, elements or compounds bond together. Again, it's a fixed ratio. Properties are different from their individual elements. Again, chemical bonds hold them together. Example, table salt, NaCl, okay? Sodium chloride has got completely different properties than that of just pure sodium or just pure chlorine. So the compound properties are different than the individual elements, okay? Chemical formulas represent the compounds, okay? The number of each atom is represented by a subscript after the element. If only one atom is present, no subscript is written. So Na2SO4, we have two sodium atoms, one sulfur atom because there's no subscript after it, and four oxygen atoms. So that's how you write a chemical formula. Mixtures. Combination of two or more pure substances. The combination or the composition is not fixed. It can be physically separated. So what I mean by this is that we can change the ratio of a mixture. So if we have salt water, I can change the ratio of salt to water, but I can't change the composition of salt and water. Salt is going to be NaCl, water is going to be H2. I can't change the composition of salt and water, but I can change the ratio. We could have a 1-to-1, I could have a 1-to-2, a 2-to-3, but I can't change NaCl and H2O, okay? So that's what I mean by a mixture, okay? Heterogeneous mixture, noticeably different parts from each other. Italian salad dressing, Chex Mix, salt and pepper. You can see the individual parts. You can see the oil. You can see the seasoning. You can see the pretzels. You can see the Chex Mix. You can see the white salt. You can see the black pepper, okay? You can see the individual pieces. Homogeneous, look, oh, sorry.
Tenth grade, last name's L through R to the East Cafeteria for pictures.
Sorry about that overhead announcement. Homogeneous mixtures, substances are evenly distributed, looks the same throughout. So Kool-Aid, it looks just like red liquid, okay? Blood, again, red liquid. You can't see the individual pieces to it. It just looks like one color liquid. It just looks the same. You can't see the individual molecules for it, okay? Classification of mixtures based on the size of the particles. So we have solution, suspension, and colloid. So based on the size of the particles that we have. So solution, homogeneous, smallest particles, can't be separated, can't be filtered. Rubbing alcohol is isopropanol alcohol and water. Rubbing alcohol is about 70% isopropanol alcohol and 30% water. You can't separate it out. Air, nitrogen and oxygen, and there's argon, and there's water vapor, and there's a whole bunch of other things in there. We can't separate them out. They're all together. They're too small. Suspension has the largest particles, and what happens is they separate into layers over time. That's why it says, like on those naked juice drinks, that you have to shake before consuming, because over time the large particles separate out into layers, and you need to mix those layers back up again in order to enjoy a nice fresh glass of juice. So fresh squeezed lemonade, the particles settle to the bottom, you mix them up so that it all is nice and tasty for you, okay? Colloid is the middle size particles. They're the in between the solution and suspension. They can't be separated and they can't be filtered out. But they are bigger than a solution. So milk, okay? Milk is a colloid. Clouds are colloids. Smoke is a colloid, as is mayo, okay? And what those are is the particles are big enough so that they stay suspended in the liquid. You don't have to shake it to make it stay up in the liquid. They're small enough that they stay suspended up there, but they're big enough that they scatter light, okay? And then the last thing that I've got here is every sample of matter is either an element, and I spelled that wrong, so we'll fix that. An element. Every sample of matter is either an element, a compound, or a mixture. So we can classify anything as an element, a compound, or a mixture. And that takes care of 2.1. Now enjoy some practice as we classify our mixtures. Good luck.